So, dear friends, last time we were trying to see at the definition of the enthalpy of formation from multiple data. That was still under indirect definition, enthalpies. So today, we are on still indirect definition of enthalpies, but we're going to see where is the three. So 2 was the definition of multiple data. Now 3 is the definition of enthalpy reaction from formation data. So no matter the reaction that I will give to you, I'm going to give you a formula. So the formula is basically the value of reaction equals summation. There's an end of formation of the products minus summation at the end of formation of the reactants. So the product minus reactant. But for this reaction or for this formula to work, the reaction has to be balanced because this formula makes in consideration the many equations. So the equation has to be well balanced. If not, it's 0. So the equation has to be balanced because this equation I also have to do something because there's something very important. NB, look at the net. The enthalpy of formation, the enthalpy of formation of an element in its normal physical states is 0. You will see the sentence very short like this, but very significant. The enthalpy of formation of an element is normal physical state is 0. What is the physical significance of that? When they will give you an exercise where there is an element in normal physical state, nobody will tell you that the enthalpy is 0. You have to know. When I speak like this, when I just read like this, is so you just as it strike on your heads, in your ears, in the bounce. So let me explain the simple terms. If you have an element that is not combined with another, that means it's not a compound. Like oxygen, molecules, halogens, called chemistry. Halogens are represented by X. Halogen, that is fluorine, chlorine, bromine, iodine, acetane. All of them, their enthalpy of formation is 0. Nitrogen, hydrogen, 0. And they will not give it to you, and some of you will be asking it, saying that there's an error in the equation. There's no error in it. If they don't give it to you, that means you are not supposed to give it to you. So the enthalpy of formation of an element is normal physical state is 0. Let's take a typical example where we are going to be making use of this enthalpy reaction. Example. Example. Calculate. Example 1. Okay. The intern of the reaction 2SO2 plus O2 giving 2SO3. They give us some data. Data formation of SO2 is plus 198 kilo. The area of conversion of SO3 plus the addition ferrous square.
So let me read example 2. Example 1. So example 1 says calculate the enthalpy of the reaction below. The reaction is 2SO2 plus O2 giving 2SO3. So the reaction is reversible reaction.
So don't write inside of the reversibility. Reversibility.
But let's analyze the data that gives us. We get the enthalpy formation of SO2. We get the enthalpy formation of SO3. What exactly? Oxygen. So it's not for fancy that I'm not giving for oxygen. What am I just going to tell you? The enthalpy of formation of an element in its normal physical state is 0. Meaning for oxygen here will be oxygen here is 0. So let's apply the formula. The direct reaction is equal to summation. The direct formation of the products minus
the direct formation of the reactants.
Remember what I told you guys, we make use of the superlative engine. The product in this case is what? It's SO3. So I multiply SO3 by 2. So you're going to be 2
into SO3 302 minus.
I have 2 guys because I have 2 reactants.
I have SO2 and oxygen. But remember, I fill up SO2 as 2, so I make use of gradient. It's going to be 2 into 198 plus 0. 0 is that the oxygen. So punch. So to punch. So I have 2. 2 times 372. Answer. 744 minus 2 times 196. 306. Negative. What's this? What's this square here? What's it? Here.
minus. That's it. Okay. So that's how I usually teach. I usually give 2 examples today. First one example, I have 3 solutions. So example 2.
Calculate.
Enthalpy of the reaction.
Methane plus oxygen giving carbon dioxide plus cooking water. Methane plus oxygen giving carbon dioxide plus 2 water. So let me give you a type of proof. There is a formation of methane plus call it 18. It's an formation of C3. Yes. Voilà. Le BM chronique of body. Là, on est à 86.
All of these values are included in the wood. Calculate the enthalpy of the reaction CH4 plus 2O2 giving CO2 plus 2 water. I'm not giving for water, I'm not giving for oxygen. Does that mean that the reaction or the equation is wrong? It's not wrong. It has no problem. Why? Because the enthalpy of formation of an element in its normal physical state is 0. Even though the 2 here, the 2 there is significant, just the 2 equation. Even if you take 2 times 0, is 0. So that's the question, but I am about to apply the formula. So let me apply the formula. Application of formula. Delta. The value of reaction equals summation. The value of formation of the product minus the inner formula of the reactants. The product in this case has 2 pull-up, has CO2, have water. So you have to be bracket. The other CO2 is 196. Oh, spin. Plus water. Don't forget, in front of water, the 2. We bring you the regulation 2. Make the 2. And what? 2. It is minus methane 480 plus 2 into 0. We all know why I'm putting 2 is 0 because oxygen is 0. Enthalpy of formation times 2. That's 2 times 0 that's 0. 2 times 0 that's 0. That's 180. So the value of reaction equals. Take off.
Oh yes, see? Gosh, 2 times 2, it's 6. So 988 minus 4, 80. Prime letter 8 kilogram.
So this marks the end of lesson 4. So as 5 now the monomer
The bonus lesson 5 now allows to see bond energy details.
So bond energy details. In that case, although making of maths is like simultaneous equation.
So if you guys have not mastered simultaneous equation in maths, you will see the opportunity to master simultaneous equation now. So we're going to see bond energy details. So bond energy details. 1 enter. It is a sound. It's great.
So, under this bond energy theory, the bond energy, first of all, this is the energy required to break a single covalent bond in a range of covalent. So, what is the two main aspects here? Or is energy required to break a single covalent bond in a covalent compound? So, this is about two main aspects. It's the termination of the enthalpy of reaction when the bond energies are given.
Both energies.
So I'm going to give you the formula. The direction of reaction in this case is summation bond energy of the reactants minus summation bond energy of the product. So BR stand for bond energy of reactants. BP mean bond energy of product. I have one the direction of reactant equals to summation bond energy of reactant minus summation bond energy of the product.
In this case now, we're going to take a typical example here. So, like this thing used to come in GCE exams, like what came in 2015, 2025, sorry, the year before last.
They asked you they asked you to determine the enthalpy of reaction when they are giving you the bond energies in a tabular form. You have to make use of it. So writing this is beautiful. The enthalpy of reaction equals to summation bond energy of a reactant minus summation bond energy of the product.
Do you know how to apply this? Question mark. And also here we're going to make use of the stoichiometric relationship. Very important. The stoichiometric relationship.
Example. Consider the reaction below.
Consider the reaction. We have 18 plus
Having
giving 18 18 plus hydrogen giving 18. For example, 18 plus hydrogen.
this reaction is a hydrogenation reaction. You all know that hydrogenation means the addition of hydrogen. The addition is a syn addition, meaning the hydrogen and the cell either side.
So in this case, we're moving from a saturated and unsaturated compound to a saturated compound.
So I'm asked to calculate the enthalpy of this reaction. So let me complete the equation. Calculate
the enthalpy of reaction.
beta.
This is C because all the levels. This is the level of Edenante. This is 9. This is equals to theory 8.
So I'll copy the equation here because there is a bit to talk. So let's copy the equation. That's the equation, but we have this alkene compound plus 8 within that 18 compound.
Why you have to calculate the enthalpy of this reaction? Huh? So,
We make use of the formula. So the initial reaction equals to summation BE BR minus summation BEP